Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing removal with or without replacement in the context of probability. So in this question, we're told another box contains 7 black pens and 8 orange pens only. 2 pens are chosen at random from this box without replacement. Calculate the probability that at least one orange pen is chosen. So the experiment here is an experiment of choosing 2 pens, and we will not replace the first pen after picking it out. So in order to get one orange pen, we have 3 scenarios. We can get orange followed by black, or black followed by orange, or orange followed by orange. So we can get the probability of each of these scenarios and then add them up together. So if we pick orange, we get 8 over the total. The total is 8 plus 7, which is 15. And then we pick a black pen, so we have 7. But now the total is 14 since we did not replace the orange pen after replacement. So this would be the first probability. And we can use the calculator to figure this out. So 8 times 7 is 56. And this is divided by 15 times 14, which is 210. And 56 divided by 210 gives us 4 over 15. So this is the probability of the first scenario. In the second scenario, we start with a black pen. So we have 7 over 15 times, and then we pick orange. So we have 8, but the total is now 14. And of course, this is the same as the scenario above. So we're going to get 4 over 15 again. Finally, we are going to pick orange followed by orange. So 8 over 15 times 7 over 14. Now, here it is 7 because, not because of the 7 given in the problem, but it's 7 because we reduce 1 from the 8 orange pens because we already chose 1 orange pen. So now we have 7 left out of 14. And if we multiply those out again, we're going to get 4 over 15 as well. And then we add the 3 probabilities up. We get 12 over 15 as a final answer. Of course, we can reduce this and we can divide by 3 and we could get 4 over 5 as a final answer. This is the standard way of solving the problem. However, there is a smarter and faster way. Whenever you're told at least something, then the quick way to solve this is to do 1 minus the opposite. So what is the opposite of at least one orange pen is chosen? So at least one orange pen means either 1 or 2 orange pens. And you can only have 3 scenarios here. You can either have 0 orange pens, or 1 orange pen, or 2 orange pens, because the experiment consists of drawing 2 pens. So you cannot get 3 orange pens, for example. Excuse me. This is not a proper outcome for this experiment. So since you're only taking out 2 pens, so the maximum you can get is 2, or 0, or 1. So at least 1 orange pen means either 1 or 2. So the opposite here would just be 0 orange pens. So we can get the probability of 0 orange pens as black, black. And this would be 7 over 15 multiplied by 6 over 14. And then this would be, so 7 over 15 multiplied by 6 over 14 would be 3 over 15, which is simplified to 1 over 5. And then you would do 1 minus answer, and you would still get 4 over 5 as a final answer. Of course, this is much faster than the first way with which we solved the problem. So as a keyword here, it's a good idea to use 1 minus when you have the word at least. The marking scheme here says that the answer is 168 divided by 210, and this is equivalent to 4/5. So it's just not simplified, but it is the same as 4/5. Both of these are correct answers here. In this question, we are told box A and box B each contain blue and green pens only. Rafael picks a pen at random from box A. Paulo picks a pen at random from box B. The probability that Rafael picks a blue pen is 2/3. The probability that both Rafael and Paulo pick a blue pen is 8/15. Find the probability that Paulo picks a blue pen. Find the probability that both Rafael and Paulo pick a green pen. So we have two events here, and we can draw a tree to represent them. So for the first event, we are discussing what Rafael will do. So Rafael can either pick a blue or a green pen. So Rafael blue and Rafael green. And then for each of these scenarios, Paulo can either pick a blue pen or a green pen. So we can draw a tree to represent this problem. Paulo blue and Paulo green. Now, the probability that Rafael picks a blue pen is 2/3. So this is here 2/3. And then for Rafael green, this would be 1/3 because it's 1 minus 2/3. And then for Paulo, we don't know what the probability is, but we know that the probability that they both pick a blue pen is 8/15. So let's call this X. We should know from watching the video on probability trees that 2/3 multiplied by X gives us 8/15. So we can simply get X as 8/15 divided by 2/3. You can flip the second fraction and multiply instead. So 8/15 times 3/2. And this gets us 1 and 5 and 1 and 4. So the answer would be 4/5. So X here is 4/5. We can remove the X now. We can write instead 4/5 and 1/5. So these are the quantities here. So the probability that Paulo picks a blue pen, which is PB, is the probability of 4/5. And now we want the probability that both Rafael and Paulo pick a green pen. So the probability that they both pick a green pen is going to simply be 1/3 times 1/5. Because green and green means that we are walking down this path here. So 1/3 times 1/5, this gives us 1/15 as a final answer. Let's check the marking scheme. So A is 4/5 and B is 1/15. And we seem to be on the right track. The diagram shows two sets of cards. In I, we are told that Jojo chooses two cards at random from set A without replacement. Find the probability that the two cards have the same number. So in this case, Jojo is going to draw 2 times. So in the first time, she can get either 1 or 2. And in the second time, she can also get 1 or 2. Now, in order to get 1 on the first run, she has to pick 2 of the cards out of the 5 total cards. So we have 2/5. And here we have 3/5. Now, after picking the 1, she now has 1 1 and 3 2s remaining. So in order to pick another 1, it would be 1/4. And here we would get 3/4. If she had picked a 2 from the first try, she would have 2 1s remaining out of 4 total cards, and here as well, 2 2s remaining out of the total 4. we want the probability that the two cards have the same number. So it's either going to be 1 and 1, which is 2 over 5 times 1 over 4, or 2 and 2, which is 3 over 5 times 2 over 4. We would need to add these two values together. So 2 over 5 times 1 over 4 is 1 over 10. 3 over 5 times 2 over 4 is 3 over 10. And if you add these up together, you would get 4 over 10, or simply 2 over 5 as the answer. In double I, we're told Jojo replaces the two cards. So we're going to start over. Kylie then chooses one card at random from set A and one card at random from set B. Now for Kylie, we can also draw a probability tree, but on her first attempt, she chooses from set A, so she can either get a 1 or a 2. And from the second attempt, she can either get 0 or 1 or 2, since she has the three options in set B. So we have 0, 1, and 2. We need to write down the probabilities here. So for the first attempt, she can get a 1 with a probability of 2 over 5 and a 2 with a probability of 3 over 5. In the second attempt, she can get 0 with a probability of 1 over 5. 1 has a probability of 3 over 5, and 2 has a probability of 1 over 5. Same thing, of course, down below, since these are two different sets, so they're not affected by each other. So we have 1 over 5, 3 over 5, and 1 over 5 again. Now we want the probability that they have the same number. So she can either get 1 and 1, which would be 2 over 5 times 3 over 5, which would be 6 over 25. Or we can get 3 over 5 times 1 over 5 here for 2 and 2. So 3 over 5 times 1 over 5. This gives us 3 over 25. So the total here would be the summation of these two values, and we would get 9 over 25 for double I. In triple I, we are asked who is the most likely to choose two cards that have the same number. Show all your work. So we want to compare 2 over 5 and 9 over 25. So 2 over 5, to get it with a denominator of 25, we multiply by 5 up and down. This would be 10 over 25. 10 over 25 is greater than 9 over 25. So therefore, Jojo is more likely. In question B, we are told we have set C, and Lena chooses 3 cards at random from set C without replacement. Find the probability that the third card chosen is numbered 4. So we can draw again a probability tree to understand this. So she can choose a 4 or a 5, followed by 4 or 5, and here as well, followed by 4 or 5. Now, if she chooses 2 4s, we cannot really say that she can get a 4 here, because there are no more 4s to choose. So here the probability is actually 0, and here the probability is actually 1. But for the other scenarios, this isn't the case. She can choose 4 over 5, 4 or 5, I mean, and this would not be a problem. Now let's calculate the probability for each case. For the first run, she has 2 4s and 3 5s, so this would be 2 over 5, and then this would be 3 over 5. And for the second run, if she chooses a 4, there are now 4 cards left, only one of which is a 4. So this would be 1 over 4, and this would be 3 over 4. However, if she chooses a 5 at the beginning, so now she still has 2 4s to choose from, and same thing for the 5. Now on the third run, if she already chose 4 and 4, like we said, it would be 0 here and 1 here, because there is no way she can get a third 4. However, if she chose a 4 and a 5, So she still has 1 4 remaining. So we can write here 1 over 3. We can write here 2 over 3. And then for the 5 and then the 4, this is the same idea again. She has 1 5 and 1 4 already. So 1 4 remains here. So we can write 1 over 3. And here we can write 2 over 3. And then for 5 5, we can write here 2 over 3 and 1 over 3. Now we want her to get a 4 on the third run. So we want these 3 outcomes here. So we can trace the paths for each. So the first path is this path here, 4 and then 5 and then 4. So we multiply these 3 numbers together. That would be the first scenario here. Let's write it down. We have 2 over 5 multiplied by 3 over 4 multiplied by 1 over 3. And then for the second scenario, we want to get the 4 here. So we go 5 and then 4 and then 4. So this number multiplied by this number multiplied by this number here. So 3 over 5 times 2 over 4 times 1 over 3. And then finally, for the third scenario, she would have to pick a 5, followed by another 5, followed by a 4. So we have 3 over 5, 2 over 4, and 2 over 3. 3 over 5, 2 over 4, and 2 over 3. This would be the third scenario. And now we simplify. So in order to simplify, we can just cancel 3 and 3. We can cancel 2 and 4. We get here 2. So this scenario here is 1 over 10 plus, and then we cancel 3 and 3. 2 and 4, we get 1 and 2. So this is again 1 over 10. And then for the third scenario, we can also cancel 3 and 3. And then here 2 and 4. This becomes 2. And then we cancel these out together. We get 1 over 5. So 1 over 10 plus 1 over 10 plus 1 over 5. This gives us a total of 2 over 5 as the final answer. So we are given here the answer. So 8 over 20 for I, this is the same as 2 over 5. 9 over 25 for double I is correct. Jojo for triple I. And 24 over 60 in B is the same as 2 over 5. So we seem to be in line with the marking scheme. In this question, we're told the diagram shows 5 cards. 2 of the cards are taken at random without replacement. Find the probability that both cards show an even number. So in order to get 2 cards showing an even number, the person can either draw a 2 followed by a 4 or a 4 followed by a 2. And since there is no replacement, then they cannot draw 2 and then 2 or 4 and then 4 again. Since once they draw a card, they no longer have it in the set. So this would just be 1 over 5 times 1 over 4. And same thing here, 1 over 5 times 1 over 4. So this gives us 1 over 20. This gives us 1 over 20 as well. And we add them up. So we get 2 over 20 or 1 over 10 as a final answer. So 2 over 20 here is the correct answer. 1 over 10, of course, would also work. Esme has a bag with 5 green counters and 4 red counters. She takes 3 counters at random from the bag without replacement. Work out the probability that the 3 counters are all the same color. So they are either green or red. So she can either take out red, 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 or green, green, green. Since we said or, we have to add. So red, red, red would be 4 over 9 because the total here is 9. And then we remove one red counter, so we have 3, and now the total is 8. And then we remove another red counter, so we have 2, and the total is 7. We can simplify, of course. So 4 with 8, this gives us 2 and 1, and then the 2 crosses out the 2. 3 and 9, we get 1 here, and we get 3 in the bottom. So we just have 1 in the numerator, and we have 3 times 7, which is 21 in the denominator. Now for green, we have 5 over 9, and then 4 over 8, and then 3 over 7. So in this case, again, the 8 and the 4 gives 1 and 2. And there is nothing else to simplify, so we have 15 divided by 9 times 2 times 7. 9 times 2 times 7 gives us 126. Now we add these up together. So 1 over 21 plus 15 over 126. The answer is 1 over 6. And 1 over 6 here is the correct answer. Angelo has a bag containing 3 white counters and X black counters. He takes 2 counters at random from the bag without replacement. Complete the following statement. The probability that Angelo takes 2 black counters is X over X plus 3 times what? So of course, when he takes out one of the black counters, the remaining number here is X minus 1. And the total was X plus 3. So now it's X plus 3 minus 1, which is, of course, X plus 2. So this is what we should add to this fraction here. Now, in double I, we are told the probability that Angelo takes 2 black counters is 7 over 15. We already have an expression for this, so we just equate the expression to this fraction here. So we have X times X minus 1 over X plus 3 times X plus 2. And this is equal to 7 over 15. We are required to show that this expression in A, and we can just cross multiply. So we can simplify first. So X times X is X squared. X times negative 1 is minus X. So we simplify this expression. And in the denominator as well, X times X gives us X squared. X times 2 gives us positive 2X. Here we have positive 3X, and here we have positive 6. So we cross this out as well. So now we can cross multiply, things will be easier. So 15 times X squared minus X equals 7 times, of course here 2X and 3X gives us 5X. So 7 times X squared plus 5X plus 6. And we can distribute and solve. So 15X squared minus 15X equals 7X squared plus 35X plus 42. We take everything to the left-hand side. So 15X squared minus 15X minus 7X squared minus 35X minus 42 equals 0. And then we subtract. So 15X squared minus 7X squared gives us 8X squared. Minus 15 minus 35 gives us minus 50X. Minus 42 equals 0. We can divide everything by 2. And by dividing by 2, we reach the desired expression, which is 4X squared minus 25X minus 21 equals 0. In B, we are required to solve by factorization. So to solve by factorization, we must understand that we are looking for 2 numbers that are multiplied to give 4 times 21, which is 84. And then their difference, A minus B, gives us negative 25. So we need to look for 2 numbers that multiply to 84 and subtract to negative 25. So let's try to look at the numbers that give 84. So 1 times 84, 2 times 42, 3 times. So we want 3 times something to give us 84, and that something would be 28. And the difference between 3 and 28 is 25. So this is the pair that we are looking for. Since it's negative 25, so we want negative 3 and, we want positive 3 and negative 28. So the two numbers are positive 3 and negative 28. Now we write our brackets down. So we have 4x plus 3 and 4x minus 28. Of course, the 4 and the 28 can simplify. So this becomes x minus 7. Now we have 4x plus 3. So I'm going to just continue below. We have 4x plus 3 times x minus 7 equals 0. So either 4x plus 3 equals 0, in which case x is negative 3 over 4, or x minus 7 equals 0, in which case x equals to 7. And these are the two solutions for B. Now, in order to solve C, we want to write down the number of black counters. So of course, the number of black counters is 7, because it cannot be negative 3 over 4. This does not make sense as a physical quantity. And these are the correct answers here. And 7 is the correct choice for C. A group of 200 people were asked which city they would like to visit next. The table shows the results. A person from the group is chosen at random. Write down the probability that this person would like to visit either Paris or Tokyo next. So the probability would simply be 48 plus 46 divided by the total, which is 200. So 48 plus 46 gives us 94. So 94 over 200 is the correct answer here. Of course, 94 is the same over 200 is the same as 47 over 100. So this is the simplified version. In B, we are told two people are chosen at random from the group of 200. Find the probability that one person would like to visit London and the other person would like to visit New York, and give your answer as a percentage. So we can either get London followed by New York, or New York followed by London. So London followed by New York would be 50 over 200 times 56 over 199, or New York followed by London, which would be 56 over 200 multiplied by 50 over 199. And of course, you can tell that they will both give you the same result, since they both have the same numerator and the same denominator. So the numerator here is 2,800. And the denominator would be 39800, 39,800. And same thing, of course, for down below. And we still need to add them up, but first let's simplify them. So the simplest form for this fraction is 14 over 199, up and down, and then we add them up together. And we get 28 over 199. And we want this as a percentage. So this would roughly equate to the following. 14%. So when we add these up together, we roughly get 14%. So 14, or to be more accurate, it's actually 14.1%. This is the more accurate answer. This is the answer they're looking for in the marking scheme. And in A, they have 94 over 200, which is the same as 47 over 100, of course. So this means that we are on track. A box contains 20 packets of potato chips. 6 packets contain barbecue flavored chips. 10 packets contain salt flavored chips. 4 packets contain chicken flavored chips. Maria takes 2 packets at random without replacement. Show that the probability that she takes 2 packets of salt flavored chips is 9 over 38. So this probability here would simply be the following. It would be 10 over 20 multiplied by 9 over 19. And this gives us 9 over 38. Double I says, find the probability that she takes 2 packets of different flavored chips. So there are 2 ways of solving this problem. Either we tackle it directly, so we just visualize all the possible scenarios. So either she picks barbecue followed by salt, or salt followed by barbecue, or barbecue followed by chicken. But this will be a very long list of possibilities because the scenarios of different flavor chips are so many. So this becomes very tedious to compute. So instead, I'm not going to do that. I'm just going to go with the shorter scenario because the opposite here is much easier to calculate. So I'm just going to calculate 1 minus the opposite result. What is the opposite result here? Instead of picking different flavor chips, she's going to pick the same flavor chips. So it's 1 minus the probability of same flavor. What is the probability of same flavor? So probability of same flavor is the following. Either she gets salt, salt, or she gets barbecue, barbecue, or she gets chicken, chicken. Now we already calculated salt, salt in question AI. We got this as 9 over 38. And then barbecue, barbecue would be, we can calculate these on the side just to give ourselves some space. So barbecue, barbecue would be 6 over 20 times 5 over 19. And that would give us 3 over 38. And chicken, chicken would be 4 over 20 times 3 over 19. And that would give us 3 over 95. So now we just plug them in and add. So we have 9 over 38 plus 3 over 38 plus 3 over 95. And we add these up and then we subtract 1 minus the answer. So 1 minus 9 over 38 plus 3 over 38. I'm writing it down on the calculator as fractions. And we have 3 over 95 for the third one. And 1 minus all of these gets us 62 over 95. So this would be the final answer to double I. In B, we are told Maria takes 3 packets at random without replacement from the 20 packets. Find the probability that she takes at least 2 packets of chicken flavored chips. So let's write down the scenarios that satisfy this requirement. So to take at least 2 chicken flavored chips, she needs either to get CCS or CSC or SCC or CCB or CBC or BCC. Of course, C is chicken, B is barbecue, and S is salt. And then, of course, she can get CCC. These are the scenarios for which she has 2 or 3 chicken flavored chips in her selection. Now let's convert these into probabilities. So there is a smart way here to figure this out. Let's just calculate CC and simplify it. So probability of CC would be 4/20 multiplied by 3/19. And you can tell that they all have C and C at some point. So 4/20 times 3/19 is the following number, 3/95. And then in each case, we're going to multiply by another letter. So in a sense, the first one is 3/95 times picking one salt afterwards. Now picking the one salt afterwards would be 10/18. So this is the basic idea. And then this value here would be 30 divided by 95 times 18, which is 1/57. Now, this is the probability of CCS. It's also the probability of CSC and SCC, because the order will not affect the probability. So this is also 1/57, and this is also here 1/57. Now, starting the barbecue, we still have 3/95, but this time the third option is not 10/18. It's not salt, it's barbecue, which is 6/18. So this gives us 1/95. And now this also follows through for CBC and BCC as well. And then finally, for CCC, we have 3/95, and then one more chicken. So we have we have 2/18, because she already picked out of the 4 available packets of chicken, she already picked 2, and we're picking the third chicken pack. So we have 2 left to pick from out of a total of 18. So this is 2/18. And now this is going to be 6 divided by 95 times 18, which is 1/285. So the total probability would simply be the following: 1/57 times 3 plus 1/95 times 3 plus 1/285. And these would all give us the final probability we're looking for. So let's write it down on the calculator. So 3/57 plus 3/95 plus 1/285. And that gives us 5/57 as a final answer. Let me briefly or quickly explain what I did here. So instead of calculating all of these scenarios one by one, which would have been very boring, I just noticed that they all have C and C. Each of them has C and C. So I just calculated C and C once to make life easy for myself, and I got 3/95. So each time I'm going to multiply 3/95 by the third letter. And the position of the third letter does not matter. So whether the S is at the beginning or the middle or at the end, this doesn't matter. As long as you understand that there were 20 packets, so the remaining has to be 18 packets in total. And for salt, you have 10 salt chips, so it could be 10/18. This is 10/18 here. For barbecue, it's 6/18. And for chicken, it's 2/18, because you already withdrew 2 of the available 4 packets. This is the main logic of the answer. And we multiplied by 3 in the first 2, but we did not multiply by 3, of course, in the last scenario, CCC, because this can only happen in one way, as opposed to CCS, CSC, and SCC, and so on and so forth. So now let's check the marking scheme for the answer. So for double I, we have 62 over 95, and for B, we have 5 over 57. In this question, we are told bag A contains 3 black balls and 2 white balls. Bag B contains 1 black ball and 3 white balls. And this is evident in the drawing. A ball is taken at random from each bag. Show that a black ball is more likely to be taken from bag A than from bag B. So the probability of taking a black ball from bag A would be 3 over 5. This is probability of A. And then probability of B, which is taking a black ball from B, would be 1 over 4. So in order to show that one is greater than the other, we need to have a common denominator. So we can say that probability of A equals, and then we multiply up and down by 4 in order to get a common denominator. So this gives us 12 over 20. And then probability of B, in order to get a common denominator, we're going to have to multiply by 5 up and down. And this gives us 5 over 20. Then we just say that probability of A, which is 12 over 20, is greater than probability of B. This is how we show that a black ball is more likely to be taken from A than from B. Let's check the marking scheme for I. And this is how we can do it. Either 12 over 20 and 5 over 20 like we did, or we can convert it to percent, but this is not necessary. Our technique works just fine. So moving on. In double I, we are asked to find the probability that the two balls have different colors. So there are two ways that this could happen. We can either get white in A, so let's call this WA, and at the same time, let's just write this within the bracket, black in B, so white in A and black in B, or means plus, we can get black in A and white in B at the same time. So what's the probability that we get white in A? Let's evaluate one of them, each one at a time. So probability that we get white in A is equal to 2 over 5. Because we have here 2 white balls and a total of 5. And the probability to get black in B is 1 over 4. And this sign and means that we multiply them together. So we get 2 over 20 as a final outcome. Now, for the second expression, we want to get black in A. So we have 3 black balls out of 5. So 3 over 5. And then for white in B, we have 3 white balls out of a total of 4. So this would be 3 over 4. And again, they are multiplied together. So this gives us 3 over 5 times 3 over 4, which is 9 over 20. And either this could happen or that could happen. When I say or, I have to add the two probabilities together. So the final answer would be 11 over 20. Now let's check the marking scheme. So 11 over 20 for AII is the correct answer. In B, we are told the balls are returned to their original bags. 3 balls are taken at random from bag A without replacement. Find the probability that they are all black. So in this case, we are just focusing on bag A. We want to take black balls in sequence. So we begin with the first black ball. Probability of getting the first black ball will be 3 out of a total of 5. Now, this is without replacement, which means that once we take the black ball, we do not return it to the bag. So to get another black ball, we only have 2 black balls left because we already took out 1 black ball. So now we have 2 black balls left out of a total of 4. And then once we take the second black ball out, we are left with 1 black ball out of a total of 3. So therefore, our answer is going to be 6 over 60, which is the same as 1 over 10. Now we want the probability that they are all white. So we're going to calculate this. I'm going to do it systematically, even though you can think about it logically. So the answer here is going to be 0. But let me show you systematically how to do it, and then I'll show you how logically you can just say that the answer is 0. Now, let's take the first white ball out. So we have 2 white balls out of a total of 5. And then after taking the first white ball out, we can cross out 1 white ball. We now have 4 balls in total, and 1 of them is white. So this would be 1 over 4. And then after taking the second white ball out, we no longer have any white balls in the bag. So the third probability is going to be 0. You can say 0 over 3, or you can just say 0. It doesn't really matter. So the answer here is going to be 0. Of course, you can always think about this mentally. If you're going to take 3 balls without replacement from bag A, it is impossible to achieve this successfully because you only have 2 balls. So the probability that they are all white is 0. This can never happen, can never take place. Now, the marking scheme for I is 6 over 60. 1 over 10, of course, is correct as well, but 6 over 60 is fine. And for double I, the answer is 0. In C, we are told the balls are returned to their original bags. A ball is taken at random from bag A and its color is recorded. This ball is then placed in bag B. A ball is then taken at random from bag B. Find the probability that the ball taken from bag B has a different color to the ball taken from bag A. So this is similar to AII. It's the same expression. However, the numbers will be slightly different because we're actually putting the ball that we took from A into bag B. So we either take white from A and black from B, or we take black from A and white from B. Now, the probability of taking a white ball from A is 2 over 5 because we have 2 white balls out of a total of 5, as we said before. Now we take the white ball from A and we add it to B. So now we have an extra white ball in B. And we want to take a black ball from B. So probability of getting a black ball from B is now 1 out of a total of 5 instead of 4. So instead of 1 over 4, which we had in AII, now we have 5 balls here, and 4 of them are white, and 1 of them is black. So therefore, we just multiply 2 over 5 times 1 over 5, and we get 2 over 25. In the second scenario, we want to take a black ball from A, and we have 3 black balls out of a total of 5, multiplied by a white ball from B. But now we have a black ball that we took from A and placed in B, so this ball is now black. And we want to take a white ball from B. So we have 3 white balls out of a total of 5. So the probability here is going to be 3 over 5. And this gives us 9 over 25 in total. We add them together and we get 11 over 25. Let's look at the marking scheme. 11 over 25 is the correct answer here. The diagram shows 5 cards. Donald chooses 2 of the 5 cards at random without replacement. He works out the total number of dots on these 2 cards. Find the probability that the total number of dots is 5. So let's count the dots and write them down as numbers. We have 3 dots, 2 dots, 4 dots, 2 dots, and 2 dots. So in I, we want to get a total of 5. So how can we get a total of 5 here? So let's number the cards. So let's say this is card A, card B, card C, card D, and card E. Now, in order to get 5, here are the scenarios that can happen. He can either choose A and then B, or he can choose A and then D, or he can choose A and then E, or you can reverse the order of each of these choices. So we can get BA, or DA, or EA. These are all the possible scenarios that can happen in which he draws out a total number of 5. So 3 and then 2, or 2 and then 3 in each of the following cases. Now, since they are 5 cards and they are all equally likely to be chosen, so the probabilities here are all actually equal to each other. They are all equally likely. So for the first one, A would be 1 over 5, and then B would be 1 over 4, and this would give us a total of 1 over 20, and all of them have the exact same probability because we're just choosing 2 cards out of 5, so they all have the same probability here, 1 over 20 in all of them. So the final answer is going to be 6 over 20, or 3 over 10. This would be the final answer for I. In double I, we are required to find the probability that the total number of dots is an odd number. So in I, we were required to find the probability that the total is 5. In double I, we want the total to be an odd number. What are the possibilities? He's getting 2 cards. So if both cards have an even number of dots, if they have 2 and 4, for example, the total will be 6. If you have 2 and 2, the total will be 4. So the only way he gets an odd number is to have 3 and something, 3 and 2, or 3 and 4. These are the only scenarios which would give him a total of an odd number. So we already got the probability that he gets a total of 5. We already got that in I. This is 3 over 10. The only other option is to get a total of 7. And to get a total of 7, he can either pick A followed by C, or C followed by A. And again, each of these is 1 over 20. So the probability here is going to be 2 over 20, which is equal to 1 over 10. So therefore, the total probability is the sum of these two numbers added to each other. So the total probability of an odd sum is going to be 3 over 10 plus 1 over 10. And this gives us 4 over 10, which is equal to 2 over 5. And that would be our final answer. In double I, they got 8 over 20. Of course, 8 over 20, if you simplify it, if you divide by 4 up and down, you get 2 over 5. So it's the same answer, and we are fine. This is the correct answer here. A bag contains 4 red marbles and 2 yellow marbles. Behnaz picks 2 marbles at random without replacement. Find the probability that the marbles are both red. So the probability that they are both red, R and R, would be 4/6, because there are 6 marbles in total, and 4 of them are red, so 4/6. And then once he takes out one marble, one red marble, he now has 3 red marbles remaining out of 5 in total. So therefore, the answer here would be 12/30. You can simplify this, of course, by dividing by 6, and you would get 2/5 as a final answer. And then in double I, the marbles are not both red. So it could be red and yellow, or yellow and yellow, or yellow and red, just not red and red. And the easy way out here, the shortcut, is to understand that there is no third alternative. They are either both red or not both red. You might be thinking, there is a third option because double I means that they're not both red, which means that they're both yellow, for example. This is incorrect. Not both red means that anything would work as long as it's not red and red. So since there is no third option, we can just evaluate this as 1 minus the answer to I. So 1 minus 2/5 gives us 3/5, and this is the final answer. We don't need to bother with evaluating the other scenarios because there is no third option. They're either both red or they're not both red. So the total probability has to be 1. So we just do 1 minus 2/5, and that gives us the final answer. So 2/5 and 3/5 are correct. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.